Jai Hind everyone. So today our next topic for cryptography and network security is the key distribution scenario. Before talking about key distribution scenario, we need to talk about that why we require a scenario when we want to distribute a key. Means sender or receiver wants to communicate with each other. Before that, to keep their transactions secure, to keep their communication secure, they need something which is unique, which is not shared with everyone. So two persons, sender and receiver, will be only the person who knows this key, and by using it, they can keep their transactions and information secure. So we are going to talk about that how this key distribution will take place on an open network so that every time it will remain secure and no other third person can easily access that. So for this, first of all, we need to talk about what is basically key management means. The public key encryption helps to address the key distribution problems, and it is if we will talk about it, we will talk about two important aspects. First one is distribution of public key, and second one is use of public key encryption to distribute these secret keys between them. The main target is just to keep our information secure. If we will not use these type of key management and the security issues, whatever we are facing right now, then this particular key can be easily accessible by each and everyone, which is not good. And in the open network, whosoever will be able to get that key, he or she can easily attack it and open the information which is needed to be shared securely. So for that, we need to keep the management of all these keys properly. So the distribution of public keys can be considered under any of one out of these four. First one is the public announcement, in which the sender is going to announce the key publicly, and whosoever will receive the information, he can use the key shared publicly to open the information. Second one is publicly available directory, in which a directory system will be there, as you know very well, as our phone directories are. We are having the important numbers in those directories under a particular head. In the same way, publicly available directory will consist of certain information or keys, you can say, which is available to everyone in the form of a booklet. And if anyone wants to use it, then they can use. Third one is public key authority. We are going to have a central authority system which will distribute the keys between them. And finally, the fourth one is public key certificate, in which a certificate system will take place. We will provide a key, then acknowledgement will be received. Then again, the distribution of these two keys will take place between two persons, the sender and the receiver. And each and every time we are going to acknowledge it with the help of an acknowledgement certificate. So public key announcement, in this, the users distribute the public key to recipients or broadcast to the community at large. For example, append PGP keys to email messages or post to news groups or email list. So basically what's happening over here, in public announcement, they are going to publicly disclose their keys. Whatever keys they are going to use, they are going to broadcast it to each and every recipient. Sender is the same, but there are more than one recipient for it. So PGP keys are main, which is going to be used in this. The major weakness is forgery. It is very much easy to forge in this particular scenario of public announcement. Anyone can create a key claiming to be someone else and broadcast it. Second is, until forgery is discovered, it can masquerade as claimed user. So till the time, if a person is able to create a key and broadcast it by using some other's name, it is also a possibility. And second thing is, till the time when this forgery is actually discovered, or it will come to the knowledge to each and every person, before that, up to that particular point of time, maybe it has created a big chaos. So these are the two weaknesses for this public announcement, due to which we will not encourage the use of this particular type to share the keys. Public available directory. It can obtain the greater security by registering keys with a public directory. Directory must be trusted with the properties of, it contains the name, public key entries, Second one, the participants register securely with directory. Third is participants can replace key at any time. Fourth is directory is periodically published. Fifth, directory can be accessed electronically. Still, the vulnerable to tampering or forgery. So in publicly available directory, if we are having the important keys available publicly in a booklet kind of a thing, then also it is not that much secure. But yes, it is a kind in which though two people can easily share their keys, but it is not encouraged that much. Public key authority. It improves the security by tightening the control over the distribution of keys from directory. It is much better in comparison to the two previous types which we have already discussed. This one is the better one, in which we have the improved security by tightening the control, because control is in the hands of a particular third authority which has this right to keep the keys secure and to distribute it time by time whenever it is needed by the sender and receiver. It has properties of directory. It is somehow some kind, you can say it has some of the properties similar to that of the directory system, and requires the user to know the public key for the directory. Then users interact with the directory to obtain any desired public key securely, and does require real-time access to directory when keys are needed. So like this, real-time basis on the basis of real-time basis, we basically need the updation of these kind of things. So in this diagram, you can easily understand, here A is the initiator. This A is the initiator, the person who wants to start the communication with the another party, B. This is the responder. A will initiate, B will receive. A is the sender, B will the receiver. What A will do? First of all, in this particular diagram, you can easily see, other than these two, we are having one more entity available named as the public key authority. This public key authority is nothing but it is actually going to keep the actual authority in his hands, and by time whenever any person or participants want to use the key, they will share it with them. So the initiator is sending the request along with the timestamp to this public key authority. You can see this easily. This initiator is sending the request plus timestamp. This time one will tell us that which particular time, at which particular time stamp this particular the communication started, initiated. So it is going to send a request. What request it is sending? Basically this A wants something from this public key authority. By using that secure thing, you can call it as a key, by using that it can easily receive, or you can say easily send and receive the informations to this receiver B, the another party in this complete scenario. So initiator is sending the request and timestamp first of all. After that, in response, this public key authority is sending the encrypted message. You can see here E is written over here. It means the encrypted message. Encryption with the help of the private key of authority. And this private key of authority is going to encrypt this complete message, which consists of the public key for B, the request and the timestamp. Means request and the timestamp is exactly the same thing which is already sent just before this particular message. This is statement number 1, you can say. So this statement number 1, this request and time is attached with this message as an acknowledgement that this statement B or statement 2 is nothing, but actually it is the response to this statement 1. So request and time is attached with the public key of B, which is provided to A, with the help of which now A can initiate the communication with B. It is encrypted with the help of the encryption key of authority, private key of authority. means authority, this public key authority is going to encrypt the message with his own private key and sending the public key for B. Using this, A can easily start communication with B, and side by side it is attaching the statement number 1 just as an acknowledgement for it. So it sends this statement number 2 to this initiator. Once this initiator will receive the information, now it has the public key for B. Now this A can easily start the communication. Using this public key of B, it is going to encrypt the message and sending his own identity, that is ID A, and attaching a nonce 1. Nonce is nothing, but actually it is used just to keep a particular statement unique. It is a kind of a number or a random number, you can say, which is going to be attached with each and every message every time. So here it is going to use the nonce 1. So you can see identity of A means initiator A is sending his own identity, that who I am. By seeing it, the responder B will be able to understand that who is sending the message. When it will see that this message is publicly encrypted with the public key of B, then he will come to know that maybe this information is properly, you can say, authorized by this public key authority. So this statement 3 is received on the receiver side now. Now just to cross check whether this A is a trusted party or not, the central authority, the public key authority, is having the repository in which all the recipients of that particular environment or network are registered over there. So this responder B, before starting the actual communication with A, will start a communication with public key authority just to check whether this B is a trusted party or not. So for that, this responder B is sending, you can see a request with the timestamp 2. Here you can see time 1 is written, means it is showing at which particular time this statement has executed. In this same way, this request and time 2 shows the timestamp for this particular statement. So it is sending the request along with the time 2. Now when this public key authority will receive it, it will send it back. In which way? You can see over here, the statement number 5 consists of the public key of A, the request, the timestamp 2, and all this complete message is again encrypted with the private key of this authority. You can easily compare. This is the request plus timestamp. This is the request plus timestamp. Here also the authority is encrypting the complete message which with its own private key, in which it is sharing the public key of B with A and attaching the previous information or statement together as an acknowledgement. In the same way, in this particular statement number 5, you can see that again there is a public key of A. Public key of A, the request, timestamp attached as an acknowledgement. That acknowledgement of this particular information or a statement is this. He is sending the response to this statement number 4 and encrypting this complete message with the help of its own private key. Again, authority is using its own private key. Sending it over here, you can see now in statement number 6, nonce 1 and nonce 2 are attached together, and this sender B will encrypt the message with the public key of A, send the information. After receiving it, A will be able to understand that yes, B is now ready to start communication, and further they will communicate with each other. So this is the third type, which is known as the public key authority. A third party or authority is available, and all the participants of this network are registered with this authority, and time by time whenever someone requests, then they will provide the keys for it. So the public key certificates, you can say the certificate allow key exchange without real-time access to public key authority. A certificate binds the identity to public key, usually with other info such as period of validity, rights of use, etc., with all content signed by a trusted public key or certificate authority that is named as CA, can be verified by anyone who knows the public key authority's public key. So this is the last fourth type of way for sharing the keys to keep our keys secure, that is public key certificate. This is the diagram for public key certificate. A is there, B is there, certificate authority is there. A is sending the information, means what it is sharing? It is sharing his own public key with this certificate authority. You can see what it is sending. The certificate authority is sending information in which it is attaching the identity of A, the public key of A, timestamp, and all this complete message is encrypted with the private key of authority. By receiving it, A can start communication using this CA, that is certificate authority. The certificate is sent to B. After receiving it, B will send the public key of itself. Now CB is equals to encryption with the help of private key of authority, in which again the identity of B, the public key of B, and timestamp 2 is attached. So complete this message comprises as CB. Now CB is there, this certificate is there for B. So in this way you can see the public key certificates are generated by this certificate authority and provided to A and B both. So the public key distribution of secret keys use the previous methods to obtain the public key, can use for secrecy or authentication. Both public key algorithms are slow, as usually wants to use the private key encryption to protect the message contents, hence need a session key, have several alternatives for negotiating a suitable session. So these are some of the points related to this secret key, the distribution of these keys. Keeping all these things in mind, we are going to talk about a different thing which is known as key distribution scenario. So simple secret key distribution is proposed in 1979 by Markley, generates a new temporary public key pair. A and B sends. A sends B to public key and then their identity. B generates a session key K, sends it to A, encrypted using the supplied public key. A decrypts the session key and both use it. The problem is that an opponent can interrupt and impersonate both halves of the protocol. So this is the problem, which is addressed over here. The initiator A will share a message with B which is encrypted with the help of the public key of B along with his own identity and the nonce. Then here the encryption will take place, which is with the help of the public key of A, and it is sending the nonce 1 and nonce 2. Nonce 2 is attached just to differentiate it from the first previous statement. This is the number 1, this is number 2. In number 3 you can see again A is sending a nonce 2 which is encrypted with the help of public key of B. Here you can see. And finally it is sending the session key with nonce 1 which is encrypted with the public key of B. So like this public key distribution of secret keys then takes place. Hybrid key distribution. It retains use of private key, that is KDC, that is key distribution center, shares the secret master key with each user, distributes session key using master key. Public key used to distribute the master keys, especially useful with widely distributed users, and performance and backward compatibility are the rationals. So what we are going to do in this key distribution scenario, for key distribution, the symmetric schemes require both parties to share a common secret key. Issue is how to securely distribute this key. Often secure system failure due to a break in the key distribution scheme will take place. So here we can see that the parties, A and B parties, have the various key distribution alternatives. First one is A can select any key and physically deliver it to B. If A wants to communicate with B, the first option that how these two parties are going to share their keys, first option is A will create a key and with a physical meeting, they will share the key. They will deliver it to B. Second one is third party can select and deliver the key to A and B both, which we have already discussed in our previous slides, that a central party is there, they will create a key and distribute to both the sender and receiver, which are going to establish a communication. Third is if A and B have communicated previously, can use the previous key to encrypt a new key. If already they have established some of the communications in their recent past, then using the same key they can securely share a new key for that. Fourth one is if A and B have secure communications with a third party C, C can rely key between A and B. Means if A is in a secure communication with the party C, B is also in a communication with the party C, then this C can, you can say C will act as a mediator between A and B, and they will easily relay the information or key from A to B or B to A. So the key hierarchy is required before that. Typically have a hierarchy of keys. The session key, temporary key, it used for the encryption of data between users for one logical session, then it is discarded. Second one is the master key. It used to encrypt the session keys shared by user and key distribution center. So these two kind of keys, the session key and the master key, will going to play a very important role in our key distribution scenario. So here is the actual diagram that how this key distribution scenario is represented. In this diagram, you can see there are three entities available with us. First one is the initiator A, second one is the responder B, and third one is key distribution center, or you can call it as KDC. The initiator A is going to send the identity of A, means his own identity of B, with which he wants to talk or start its communication, and third thing which is attached over here is the nonce 1. So ID A, ID B and nonce 1 is sent from initiator A to KDC. Now in response to it, this KDC is sending a message which is encrypted with the help of this KA. Now this KA is the actual master key which will be used between these two entities, that is the initiator A and the key distribution center. So this KA is nothing, it is a master key which is going to be used between these two. Now it is going to encrypt two messages. First one is this one, second one is this one. First one is encrypted with the session key, you can see. This is the encrypted with the session key. Identity of A is there, identity of B is there, and nonce 1 is there. It is sending it as the response. Then encrypted the another part of this message which is encrypted with the session key of B. Now this particular part is not accessible by the initiator A, which consists of the session key and the identity of A. When this information is received over here, you can see that initiator A will start communicating with the responder B. How it is going to respond? With the help of the session key which is provided, that is KS. It is going to encrypt his own identity with KS, and it is going to send this particular portion of the message directly from A to B. You can easily see this information over here. The second part is broken between and it is provided to the responder B. Now this responder B will send back the nonce 2, which is encrypted with the session key, A will receive it and send the function of this nonce 2, which is encrypted with the session key. So you can easily see the statement number 1, 2 and 3. These are key distribution steps, and statement 3, 4, 5 are the authentication steps. So this is a very important diagram for our key distribution scenario. Here, if we will see what are the main issues with the key distribution is the hierarchy of KDCs required for large networks but must trust each other. Session key lifetimes should be limited for greater security. Use of automatic key distribution on behalf of users but must trust the system. Use of decentralized key distribution is there, and controlled key usage is needed. So these are some of the key distribution issues. As you can see in this diagram, which we have already discussed just now, you can see very well that whenever a communication is taking place between the key distribution center and any other party, then always that particular statement or a step is going to be encrypted with the master key. That master key is not always the same. A and KDC will use a single master key for their communication. If in future B also wants to communicate with KDC, then also they are going to use the master key, but that master key is somehow different. It is not exactly the same master key. So you can say master key between these two is a different one, and master key between these two will be the another one, but we will call it as a master key. So master key always works between an entity which is going to communicate with the KDC. So KDC and any other entity is going to keep their information secure, always using their particular master keys. And entities, this A, B, C, whatsoever entities are available in this network, all these entities are going to communicate and keep their information secure using the session key. So here you can see the master key is named as KA. Maybe if this B have been going to communicate with this KDC, then obviously they are going to use a master key KB. If there is an entity C, then we can call it as KC. It is a way how we are going to represent the master keys in a complete scenario. But if we are going to talk about the session key, we are always writing the session key as KS. You can see here, this is KA and this is KS. So here N1 represents the nonce 1. This ID A shows the identity of A. This ID B shows the identity of B. Nonce 2 is the another nonce random number which is sent. It is attached with the message and sent. And finally, here we are having the function of N2. So this is the summary that what we have discussed in this lecture. We have considered the distribution of public keys. We have talked about the public key distribution of secret keys, and we have talked about the key distribution scenario. So the main conclusion of this lecture is, while we are using certain keys, it is not only important how we are going to keep our keys secure or how we are going to generate our keys, but it is also an important aspect that how we are going to share our keys with the another party securely. It is also a very important you can say aspect or topic in which we need to keep our focus, so that if keys will remain secure, if keys will be shared securely, then it will keep our messages secure on the open network. So that's all for this lecture. Thank you.